Now that we know about the 5 critical points, we can focus a bit more on its key features or properties to help us sketch any sinusoidal wave that's been transformed. We're dealing with A, K, D, and C, which are the same transformations you've been seeing for a few years now. But I'm going to outline it a little bit more clearly here with a general form, and then we'll go through an example here. So, the value of A here out front, whether it's in a sine wave or a cosine wave, that will actually tell me the amplitude. The amplitude is the absolute value of A. And it's the absolute value because, as we saw, the amplitude is always positive. Okay? So even if this is a -2, the amplitude would still be a +2. Okay, so this here is the absolute value, or the positive version of whatever A is. If it's already positive, then it stays positive. The equation of the axis, or the midline that we talked about with the general form, is actually going to be our value of C. So our equation of the axis, or the equation of the midline, is always going to be y equals whatever my C value is, which is pretty handy. I pulled right out of the formula. Now, my maximum and my minimum. So we saw that I went from my midline up to my amplitude, which would have given me my maximum. So I can use these two values here, because the value of my max will be C plus the absolute value of the value of A, right? So it could have, if this was 3, it would have been 3 plus 2. And my minimum is going to be whatever that C value is, minus my absolute value of A. Okay? And again, we'll see an example of this shortly. The period, well, we saw from the original that it is supposed to be 2 pi. Right? But if it's transformed, to calculate the period, we're going to take that 2 pi and we are going to divide it by K. And that will give us the length of our transformed cycle. And finally, we have to take that period here because we have to split that period up. Okay, so we're going to split up that period into 5 critical points, right? But we noticed that they were kind of a quarter along the way. So we're going to take that period, okay, and we are going to divide it by 4 to figure out the length between each critical point. So that's the period that we would get from that entire equation here. Finally, we're going to have those 5 critical points at this distance apart. Okay, but where are we going to start? Well, we've got one last value that we haven't used in our equation up here, and that is our value of D. We are actually going to start at that very value of D. That will be my first critical point. That means my next critical point, my second one, will be this length over from this value of D. It's going to be D plus this value here. Okay, so let me see if I can actually, can I pick all that up? No. Ooh. So I'll write it out. It's going to be this D plus the period over 4. Okay, like I said, you'll see it in a second. From here, that will give me whatever that equals is my second critical point. Then I take this value for number 2 and I add another period over 4. Okay, remember this all is coming from this part here. Okay, and I carry on from this coordinate, for my number 3 coordinate, I add another period over 4. Right? And for my final, I take this number 4 coordinate and add another period over 4. Okay, so again, it looks a little bit weird here, but when we do our example, it'll be a lot more clear. Okay, but that is the general way to find all of our key features or properties. So let's do an example and we'll see how it sketches out. Okay, so my amplitude, that is where I have to look to my A value, and it is the absolute value of 3. Well, 3 is already positive, so that works out really well. My amplitude is 3. Okay, well, what's up next? My equation of axis or my midline. Well, that comes from my value of C, and my value of C is 4. So that is going to be where my midline is at y equals 4. Okay, so you can already see that it's going to be here at 4, but we'll get there. Okay, now what about my maximum and my minimum? I'm going to take that 4, and to find my maximum, I'm going to add my amplitude, which is 3. And I'm going to get my minimum, I'm going to take that 4 and subtract my amplitude of 3. So what's my maximum here? So my maximum is going to be 4 plus 3, which is 7. And my minimum is going to be 4 minus 3, which is 1. Awesome. Next up, we have the period. So we have to take that original 2 pi and divide it by whatever my k value is. Well, let's look and find out what my k is. My k value is 2. Now we have to be very careful because this k value has to be outside of the brackets of this x minus whatever. Okay, so it's very, very important that it has to be outside of the brackets. It's going to be 2 pi divided by 2. And when that simplifies, what does that simplify to? Well, the 2's will cancel, leaving me with a period of pi. So that means the length of one cycle is only going to be a length of pi. Okay, so it's going to be in about this long. Okay, and finally, critical point. So we're going to take whatever that period is, so that's the period here, and divide it by 4. Okay, and that tells me that I'm going to have a critical point every pi over 4. So each critical point is a distance of pi over 4 apart. Well, that's not so bad. Finally, we have the coordinates, or the x values of each of my critical points. So I'm going to start at my value of d. Well, what is my value of d here? It is pi over 4. Notice that it's not negative pi over 4. Okay, I'm starting at pi over 4. So that's where my first critical point is going to be. My second critical point, I take this pi over 4, and I'm going to add the distance between each critical point, which is pi over 4 as well. Okay, so pi over 4 plus pi over 4 gives me 2 pi over 4. Now, I will reduce that later, but I do want to keep this together just as 2 over 4 and not reduce it yet, because I'm now going to take that very value, this 2 pi over 4, and that's going to go right here, because I now have to find my third critical point. So I take whatever I got for number 2, right here, okay? Take whatever I got for number 2, this value right there, and I put it here for next and add another pi over 4. Okay, so this is the process to find the x value of every critical point. And the reason I didn't reduce it is because I need to have the same denominators to add them. I will reduce when I plot, but we'll do this for now. Okay, so 2 pi over 4 plus another is 3 pi over 4. And that's what I use to now find my fourth. So 3 pi over 4 plus another pi over 4, since every critical point is pi over 4 apart, leaving me with 4 pi over 4, right? That was from there. This is all the same pi over 4 from right here. And for my fifth and final critical point, I take this 4 pi over 4 and I add one last pi over 4, giving me 5 pi over 4. All right, so that is that pi over 4. That goes there, and that goes there. So now we have everything we need to plot. Okay, so let's see what it looks like. So let's first take a look at my midline, maximum, and minimum. So my midline is at 4. My maximum is at 7. And my minimum is at 1. My max, midline, and minimum. We'll do those as dotted lines here. Awesome. Okay, so my amplitude is 3, 4 to 7, 3, 4 to 1 is 3. My period is going to be pi, so we'll check that at the very end, because now I can use my critical points. So where am I going to be starting? Well, let's look back to see what function we're working with. We're working with sine, and sine looks like this. So my first critical point will be at my midline, and then my max, and then my midline, my min, and back to my midline. So that tells me where I have to be for this. So my first critical point is at pi over 4. Well, pi over 4 is right here, pi over 4. And according to sine, my first critical point is at my midline. So at pi over 4, I'm at my midline. My next critical point is 2 over 4, or, when it's reduced, pi over 2. Perfect. And at my second critical point, I'm up to my maximum. So at pi over 2, I'm at my max of 7. Here's the x coordinate, and this tells us where we're going. I've done my first and my second. Third critical point is 3 pi over 4, which is right here. And my third critical point, 1, 2, 3, is back at my midline. So at 3 pi over 4, I'm at my midline. Check. My fourth critical point, when that reduces, those 4 cancel, leave me at pi. And my fourth critical point, 1, 2, 3, 4, is down at my minimum. So pi and my minimum. And my last critical point is 5 pi over 4. So that's right here. Is 5 pi over 4. And my last critical point, my fifth, we've done my 4. 1, 2, 3, 4, 5. Back at my midline. So now I have everything I need to sketch out. Oh, this is going to be rough. Oh! Sketch out my graph right here. And that is how we can use this general form, all of our key features or properties, and our 5 critical points to sketch one cycle of our transformed sinusoidal wave.